Good morning, students. Sorry for the delay. There was some technical issue from my side. So that's why this 5 to 10 minutes delay happened. So now come to the topic, that is fixed assignment scheme. As I told you in the last lecture, the fixed assignment scheme is that one, just like we can visualize as a circuit switching scheme and like the telephone exchange system. So what happens, why we need the fixed assignment scheme? Because the channel is shared by many of the users like ABC, and this is one channel. So the problem is there is one channel and there are a lot of users. So there may be collision occur, and the collision is not good for the communication because it can disturb all of the communication and create the noises in the channel. So this channel is acting like a resource. And this resource can be like when we divide the channel in terms of the time. So time can be act as a one of the resource, then the frequency and the code. So according to this division, in the fixed assignment scheme, we will talk about the TDMA in the today's lecture, FDMA, and CDMA. So now jump to the topic. The first topic is under the fixed assignment scheme is FDMA, that is frequency division multiple access. So in the frequency division multiple access, as I told you in the last lecture, what is the bandwidth? Bandwidth can be understood like a band and it's having some width. When the width is higher, then we can say we have lot of resources according to the frequency. So frequency division multiple access means we have to divide the bandwidth, we have to divide the frequencies. And FDMA is the process of dividing one channel. It can be termed as a channel. So FDMA is the process of dividing one channel into the multiple channels, or you can say the multiple small bandwidth. That is called band. So each band can be used by a single user. Like this is the one channel, and FDMA says that we have to divide the channel into the multiple bands. So my band will be seen like this. So this is called first frequency band, that is F1. This is F2. This is F3. And it is F4. Like one channel is dividing into multiple frequency bands. And what is that one? The whole area, it is called the channel, or you can say the shared bandwidth, which is basically accessed by all of the users in order to initiate the communication. So it is nothing but the shared bandwidth. So because there are multiple frequency bands, because a single shared bandwidth, or you can say the frequency is dividing into multiple bands. So this one, that is F1 frequency band, is allocated to one user. So the rule says you have to allocate one band per user. So if there are three persons, A, B, C, so A will be allocated the F1 frequency band, F2 will be allocated to B, and F3 frequency band will be allocated to user C, and so on. So means you can say if there are a lot of users, then we have to divide the bandwidth according to that. So there may be multiple chunks of bandwidth if the number of users are getting higher. So that's why this one is not useful for the real-time system of the communication. Like in the today's scenario, the number of mobile users are very high. So it is not possible to divide the frequency into the lot of smaller chunks of the frequency band. It will be not a great choice. It is not the feasible solution, and it will create lot of interruption as well as lot of interference in the communication. So that's why this technique is used in the cable television system. What is the cable television system? In nowadays, everyone homes have a cable TV in which lot of channels, around 700 to 800 channels are occurring. So in that way, frequency division multiple access play a role such that in your TV, multiple channels in terms of Star Plus, ZTV, and Satmax, Z Cinema, a lot of channels are there related to sports, entertainment, news, songs, movies is occurring in the cable TV screen. So what happens? There is there are two wires associated with your cable TV. Suppose it is your TV. So there are two wires. The first one is the power wire, which supplies the power to your TV. And the another one is cable system. So cable system is also associated with the power, but it is related to the antenna also. So this cable, a wire, is responsible for allocating the channels to your TV. So in this wire, it can be termed as a band, right? So in this band, it is divided into multiple frequencies band, around 700 to 800. And according to its 700 to 800 division, per sub-band is allocated to one channel. Sometimes it is possible that each of the band having the same frequency, as we can divide the bands into the multiple frequencies channel. So आपने देखा होगा कभी कभी केबल टीवी में जो हमारे channels आते हैं, the channels having a high quality like HD quality, and some of the channels not having up to the level of quality. That is the reason. So the cable TV system is one of the example of FDMA, and the bandwidth the cable system is used is fixed, that is 4 megahertz to 1 gigahertz. So let me write some theory, because in the exam you have to write the theory. So FDMA is the process of dividing one channel or you can say shared bandwidth into multiple channels multiple individual channels, or you can say band, and each band can be used by a single user. So now the problem is, according to the definition, whenever the frequency is divided into multiple bands, so this frequency band is allocated to only one user. Like in the cable television system, if the channel is divided into 7 to 800 slots of frequency band, then each channel, suppose ZTV, is allocated to the frequency band F1. So F1 is reserved for ZTV, F2 is reserved for Star Plus, and so on. So the ZTV in the Star Plus can be act as a user. So same technique can be used in the fiber optical communication system, in which the fiber optics, the wire, the frequency is divided into multiple channels. Same technique is used in fiber optical system. Now there are some basic knowledge regarding to the mobile computing. As I told you, the frequency band is allocated to one user. And FDMA says that each band, like one band, has to be allocated to only one user, but in the actual communication scenario, what happens? Each user requires two channels, not one channel. Why? Because suppose it is a mobile user and it is the base station, because I'm talking about the mobile computing scenario, not the wireless computing. So it is a mobile user and this is the base station. So for the real-time communication, for transferring of the data or for making a call, there should be two channels allocated to the users. There is a requirement of two channels. The first one is called uplink channel and the second one is called downlink channel. Okay. So uplink channel is used for initiating the communication with the mobile to the base station, and the downlink channel is used for maintaining the communication between the base station to the mobile user. Like some time of messaging is occurring from our service provider, like your data service is exhausted in 2 weeks or 2 days, kindly recharge as soon as possible. So this type of messages is going through the channel of downlink. But when we are initiating any communication, like sending a message to a friend or initiating a call or sending some certain multimedia type of things, so actually we are communicating with the base station. So mobile user uses uplink channel in order to transmit any data. The two channels are allocated to one user. Now the another scenario in the FDM is once the channel is assigned, suppose F1 is assigned to particular user 1. Okay, then this F1 channel cannot be used by the another user. So once assigned, this channel cannot be used or reused by other users in the system. Means we can say the utilization is very, very low. Suppose for a particular time user F1 is not transmitting any data, right? So if it is not transmitting any data, then this F1 frequency band is not utilized and it will remain as it is. Just like in the cable television system, you cannot see all of the channels at the same time. You have to watch a particular channel according to your requirement and according to your entertainment choices. Sometimes you have to watch the sports, sometimes you have to watch the uh, news channels, or sometimes movie, or sometimes song. So you cannot saw all of the channels at same time. So that's why the another frequency band allocated to the another channels like sports or news will be pasted and the channel utilization is low. So once assigned, other system. That's why utilization is low. The advantage over this protocol is the implementation of this FDMA technique is very simple, because you do not have to do anything, just you have a band and you have to divide this band into multiple frequency bands. That's it. So that's why implementation of this protocol is very easy. The implementation of the CDMA is tough and implementation of the TDMA is also slight tough as compared to FDMA. So that is the only advantage of FDMA. that implementation is easy. So that's why FDMA is used for the cable television system. It is not used in the real-time communication scenario. So now moving towards TDMA, let's see what is TDMA. So TDMA is called time division multiple access. So as the name indicates, in the previous FDMA, we have to divide the frequency into multiple frequency bands. So just like in the TDMA, we have to divide our resource, means the channel, in terms of the time, in terms of the slot. So what is the slot? That is, this is one slot, this is another one, this is another one, and this is another one. So like it is divided into multiple time slots. So TDMA allows user to access different on multiple channels based on the time slots. So this TDMA technique can be understood like a operating system scheduling algorithm that is called the round robin. So the round robin, according to the time, the task is scheduled. And once the time is relaunched, then the pending work has to be rescheduled, right? So just like it is a round robin fashion. Also, the disadvantage of TDMA is improper channel utilization. The channel utilization is not good because if T1 is assigned to particular user 1 and the user 1 is not transmitting any data, so this T1 time slot is not utilized. Okay, it will be ideal in that case. And suppose if there is certain another user who want to transmit the data, but none of the channel slots are free. It is acquired by user 1, user 2, user 3, and user 4, so on. But the user 1 is grabbing this T1 time slot, but actually he is not transmitting any data. So that's why the starvation problem can be occurring. So that's why the channel utilization for the TDMA is not good, just like in the FDMA. So what is the application of TDMA where it is used? It is actually works well with the slow voice data signals. And it is used in the GSM. GSM is the 2G. When the 2G was launched, so for the resource allocation, it uses TDMA as a MAC technique between the user, such that the users grab the channels for transmitting the calls, for transmitting the data. So the TDMA is launched in the GSM. So GSM is nothing but the global system of mobile communication that we will see in our further lectures. What is GSM and the GPRS? So just wait for the further lectures. So it is nothing but the 2G, in which, because they are not so much users of the 2G, so that's why the it carry 8 voice calls into one channel. So that's why the performance of the 2G was very, very bad, because the number of users are not so much. In fact, due to this, the division of this TDMA technique, like it will carry only the 8 voice calls into the one channels. The division is not in the proper format. So that's why the calling capabilities gets very, very low. So now come to the last division, that is called the core division multiple access. So the core division multiple access is also known as spectrum technology. So what is spread spectrum? Spread spectrum is invoked by the one protocol in the physical layer, that is called the direct sequence spread spectrum. So in the technique of direct sequence spectrum, what we have to do, we have to first convert our voice calls in terms of the analog signal into the digital format. Okay, so first convert these analog signals into the digital format. Once it is converted into the digital format, ये आपका analog है, and it is the digital. Once it is converted into the digital format, the protocol says that you have to spread it over the wider bandwidth with a low power level. So it utilizes the low power levels. So it is efficient for the users as well as for the subscriber. So now this digital signal is created. This digital signal is spreaded with the speed of 13 kb per second over the wider bandwidth. Here the XOR is performed between the digital signal transmitting and another one, that is called the chipping signal. So what is the chipping signal? Chipping signal is the code generator. This code generator provides the flexibility to the user such that each user can transmit the data or access the channel at any time and at with any frequency bands. And there will be no interference occurring in that case. So that's why the code division multiple access is one of the successful MAC protocol in the mobile computing. It is much complex over the implementation, because we have to first convert the digital data, analog data into the digital environment. Then we have to XOR with the chipping signal, and there is lot of circuits over there. Like the hardware, there is a requirement of the hardware in which the chipping signals are generated by the hardware in the terms of the code. And after that, we have to modulate it. So there is a modulator for spreading this chipping signal, whatever the outcome is generated, for spreading this into the wire bandwidth into the low power level. Okay? So in the last, we have to spread it over a wider bandwidth at a low power level. So that is called the DSSS, that is direct sequence spread spectrum. CDMA allows multiple users can share the channel at the same time. Okay. Now, what is the problem? The problem is DSSS uses two things. The first one is the digital data, and the second one is the chipping signal. Now, this code generator has to be work with the different users. Means this chipping signal has to be generated separately for each of the users. So each user having different code. In order to prevent from the interference with some another users, this chipping signal has to generate different code for the different users. Okay, such that each user can share only, can use only one code. Because there is a technique of reusing of the channels, and there is no permanent allocation of the channel to the particular users, but the only thing is code is different. Otherwise, the two resources like the time and the frequency can be shared with the different users at the same time. That's why the channel utilization is maximized by using the CDMA. So there is maximum utilization of the channel. So TDMA is not useful for the data transmission. That's why it is worked only with 2G. So आपने देखा होगा कि 2G सिस्टम में मल्टीमीडिया सिनेरियो काम नहीं करता था, बट आफ्टर सम टाइम 2G इज इंटीग्रेटेड विद द GPRS, और उसकी वजह से थोड़ा बहुत कम्युनिकेशन जो था वो इंटरनेट से पॉसिबल हुआ था, लेकिन वो भी अप टू द मार्क नहीं था. सो इनिशियली एट द 2G इज यूज्ड फॉर द वॉइस कॉल्स ओनली. So we can say TDMA is bad suited for the voice calls, not for the digital data transmission. But the story is different for the CDMA. CDMA works well for both the voice calls as well as the data transmission. I mean, it can work with the calling system as well as for the multimedia transmission. That's why the CDMA is launched in the 3G system. So 3G में देखा होगा कि थोड़ा multimedia जो services थी वो fast हो गई थी. Obviously, it was costly that time, but for speed and for the quality, it was good as compared to the 2G system. So work in 3G and suited with both the voice and data transmission. Now what about the 4G system nowadays? So ये जितनी भी स्टोरी है वो सारी स्टोरी 3G तक स्टॉप हो गई. 4G के लिए कौन सा यूज होता है? 4G के लिए यूज होता है हमारा OFDMA, ऑर्थोगोनल फ्रीक्वेंसी डिवीजन मल्टीपल एक्सेस, जो कि जब हम 4G पढ़ाएंगे तब हम इसको डिक्टेट करेंगे कि व्हाट इज OFDMA. So just look at example of CDMA, like what is the encoding and decoding process. So suppose there is a sender and sender wants to send a data. Data is in the digital format because I already told you that we have to convert our analog signal into the digital environment first. So my digital data is 1011. And I already told you that each sender or each user is associated with a different code. So what is the code of the sender? The code of the sender is -1 and 1. Okay, so it is just for the understanding process at which uh, you can say concept the CDMA work over. So what is the encoding technique? Encoding technique says there is one chipping signal generated. So the chipping signal initiates one algorithm. So in this algorithm, for the creation of the complexity, there are different techniques can be implemented over by the CDMA. So for the understanding point of view, I'm just using a simple scenario like we have to double the data, and there is some vector. The vector is initiated by 1 1 and 1 1. It can be termed as a constant, but you can modify it according to your preferred choices. But it can be same for all of the users. So now if you subtract it, the encoding signal will be 1, -1, 1 and 1. Okay. So this is the encoding data. Now the data is transmitted in terms of the signals. ठीक. So मेरे को इसको सिग्नल में कन्वर्ट करना पड़ेगा. So सिग्नल में कन्वर्ट करने के लिए जैसे मैंने यहाँ पे क्या बताया था, there will be XOR operation between the encoding digital signal data, this one XOR operation between the encoding signal digital data and the chipping signal, that is nothing but the code. So perform the XOR operation between the encoding data and the code. So that will be your last signal that you have to transmit over the medium. So the signal will be code, XOR and encoding data. So in that way, my code is -1 and 1. Perform the XOR operation between 1, -1, 1 and 1. So whatever the answer you will get, that will be your transmitted signal. So at the receiver, the scenario will be इसका पलट होगा, जो भी है वो इसका रिवर्स हो जाएगा. तो कोड के अकॉर्डिंग उसको भी XOR ऑपरेशन परफॉर्म करना पड़ेगा, फिर उसके बाद इनकोडिंग एल्गोरिथम चलानी पड़ेगी. So जैसे कि क्रिप्टोग्राफी में होता है साइफरमेंट एंड डिसाइफरमेंट, the same technique you have to implement over the CDMA also. So that is all about the CDMA, TDMA, and also one thing I'm missing over there. Like in the TDMA, when the channel is divided into the multiple timing slots, so in order to prevent from the interference between the timing slots, there is one guard over there. ठीक है. Same thing इसमें भी होता है, just like in the FDMA, if the channel is divided into multiple frequency bands like F1, F2, F3, F4, F5, then in order to provide interference, protect from the interference from the another users, there is one guard. So this guard is nothing but the you can say one period that cannot be utilized by any users. So along with this frequency bands, we have to provide these guard periods. ठीक है, तो थोड़े रिसोर्स मुझे अपने गार्ड पीरियड के लिए भी रखने पड़ते हैं. So if there are a lot of number of users, then according to the requirement, we have to divide our frequency bands into lot of sub bands, and according to their sub bands, this guard periods is also created. So that's why it is called the improper channel utilization, क्योंकि guard period जो है वो मेरा actually data transmission के लिए होना चाहिए, but it is used to provide the interference between the users. Same thing you have to apply over the TDMA, there is a guard period. So the resource is wasted. Resource is not utilized in the proper manner. But in the CDMA, the scenario is different. CDMA does not require any guard period because each user having different codes. ठीक है? So code अपने आप में guard का काम कर रहा है. So that's why there is no need to provide any guard period between the users in order to protect from the interference. So that's why code division multiple access is used in the 3G system. The TDMA is used in the 2G system. And the first one, that is called the FDMA, is used in the first generation communication. And the cable TV system, nowadays cable TV में use हो रहा है वो. और फर्स्ट जनरेशन जो मेरा कॉलिंग सिस्टम आया था in terms of the mobile computing, उसमें मेरा FDMA use होता था. And nowadays in the 4G there is a technique called OFDMA that we will discuss when I teach 4G communication in our further lectures. So now that is all about the fixed assignment scheme, and two schemes are also remaining. These schemes are called random assignment scheme. So in the random assignment scheme, we will learn about the Aloha system as well as the solution of the hidden terminal problem and the exposed terminal problem in my further lectures. And your MCQ for the unit 1. तो यूनिट 1 का जितना सिलेबस होगा जब खत्म होगा तो मैं आपको डिक्टेट कर दूंगी. But the timing is fixed that you have MCQ is 29 of 27. Okay. January, the first MCQ on the Moodle. So kindly register yourself on the Moodle for giving the exam. So it will be not my responsibility to enroll you in the Moodle. It is only your responsibility. So last में आप ये नहीं बोलोगे कि मुझे पता नहीं था मैं Moodle पे आपने मुझे जो है enroll नहीं किया. It is only your responsibility. So okay, that is all about the today's lecture. So if anyone has a doubt, kindly ask me. Otherwise, you can leave the meeting. So just wait a minute. I invoke in the chat. Yes, any doubts in the today's lecture? हाँ यश बताओ. Moodle पे ज्वाइन कैसे करना है? Moodle पे ऑलरेडी मोबाइल कंप्यूटिंग नाम से कोर्स है, मोबाइल कंप्यूटिंग डैश डॉक्टर निधिलाल. वहां पे आप जा करके इनरोल कर लो, सेल्फ इनरोल करना है. आपका प्रीवियस वाला भी चल सकता है, लेकिन अगर मुझे लगा कि वो फर्जी है तो मैं तुरंत ब्लॉक कर दूंगी वहां से.